How'd you go? Did you give it a shot? Did you try replicating the train step and the test step function? I hope you did. Otherwise, let's do that in this video, but this time we're going to do it for our custom data sets. And what you'll find is not much, if anything, changes because we've created our train and test loop functions in such a way that they're generic. So we want to create a train step function, and by generic I mean they can be used with almost any model and data loader. So train step takes in a model and data loader and trains the model on the data loader. And we also want to create another function called test step, which takes in a model and a data loader and other things and evaluates the model on the data loader. And of course, for the train step and for the test step, each of them respectively are going to take a training data loader. Oh, I just might make this a third heading so that our outline looks nice and beautiful. Section 7 is turning out to be quite a big section. Of course, we want them to be respectively taking their own data loader. So train takes in the train data loader, test takes in the test data loader. Without any further ado, let's create the train step function. Now we've seen this one in the computer vision section. So let's see what we can make here. So we need a train step, which is going to take in a model, which will be a torch nn.module. And we want it also to take in a data loader, which will be a torch.utils.data loader. And then it's going to take in a loss function, which is going to be a torch nn.module as well. And then it's going to take in an optimizer, which is going to be torch optim.optimizer. Wonderful. And then what do we do? What's the first thing that we do in a training step? Well, we put the model in train mode. So let's go model.train. Then what should we do next? Well, let's set up some evaluation metrics, one of them being loss and one of them being accuracy. So set up train loss and train accuracy values. And we're going to accumulate these per batch because we're working with batches. So we've got train loss and train acc equals 0, 0. Now we can loop through our data loader. So let's write loop through data loader, and we'll loop through each of the batches in this because we've batchified our data loader. So for batch xy in enumerate data loader, we want to send the data to the target device. So we could even put that device parameter up here. Device equals device. We'll set that to device by default. And then we can go x, y equals x.toDevice and y.toDevice. Beautiful. And now what do? Well, remember the PyTorch, the unofficial PyTorch optimization song? We do the forward pass. So ypred equals model on x. And then number 2 is we calculate the loss. So calculate the loss. Let's go loss equals loss function, and we're going to pass it in ypred y. We've done this a few times now, so that's why we're doing it a little bit faster. So I hope you notice that the things that we've covered before, I'm stepping up the pace a bit. So it might be a bit of a challenge, but that's all right. You can handle it. And then, so that's accumulating the loss. So we're starting from 0 up here, and then each batch we're doing a forward pass, calculating the loss, and then adding it to the overall train loss. And so we're going to optimize a 0 grad, so 0 the gradients of the optimizer for each new batch. And then we're going to perform back propagation. So loss backwards, and then 5, what do? Optimize a step, step, step. Wonderful, look at that. Look at us coding a train loop in a minute or so. Now let's calculate the accuracy and accumulate it. Calculate the... You notice that we don't have an accuracy function here. That's because accuracy is quite a straightforward metric to calculate. So we'll first get the ypred class, because this is going to output model logits. as we've seen before, the raw output of a model is logits. So to get the class, we're going to take the argmax torch.softmax, so we'll get the prediction probabilities of ypred, which is the raw logits, what we've got up here, across dimension 1, and then also across dimension 1 here. Beautiful. So that should give us the labels, and then we can find out if this is wrong by checking it later on. And then we're going to create the accuracy by taking the ypred class, checking for equality with the right labels. So this is going to give us how many of these values equal true, and we want to take the sum of that, take the item of that, which is just a single integer, and then we want to divide it by the length of ypred. So we're just getting the total number that are right and dividing it by the length of samples. So that's the formula for accuracy. Now we can come down here outside of the batch loop. We know that because we've got this helpful line drawn here. And we can go adjust metrics to get the average loss and accuracy per batch. So we're going to set train loss is equal to train loss divided by the length of the data loader, so the number of batches in total, and the train accuracy is the train acc divided by the length of the data loader as well. So that's going to give us the average loss and average accuracy per epoch across all batches. So train acc. Now that's a pretty good looking function to me for a train step. Do you want to take on the test step? So pause the video, give it a shot, and you'll get great inspiration from this notebook here. Otherwise, we're going to do it together in 3, 2, 1. Let's do the test step. So create a test step function. So we want to be able to call these functions in an epoch loop. And that way, instead of writing out training and test code for multiple different models, we just write it out once and we can call those functions. So let's create def test step. We're going to do model, which is going to be, if I could type, torch nn module, and then we're going to do data loader, which is torch utils.data.data loader, capital L there, and then we're going to just pass in a loss function here because we don't need an optimizer for the test function. We're not trying to optimize anything, we're just trying to evaluate how our model did on the training data set. And let's put in the device here, why not? That way we can change the device if we need to. So put model in eval mode because we're going to be evaluating or we're going to be testing. Then we can set up test loss and test accuracy values. So test loss and test acc. We're going to make these 0. We're going to accumulate them per batch. But before we go through the batch, let's turn on inference mode. So this is behind the scenes going to take care of a lot of PyTorch functionality that we don't need. That's very helpful during training, such as tracking gradients, but during testing, we don't need that. So loop through data loader or data batches, and we're going to go for batch x, y in enumerate data loader. You'll notice that above we didn't actually use this batch term here, and we probably won't use it here either, but I just like to go through and have that there in case we wanted to use it anyway. So send data to the target device. So we're going to go x, y equals x.to device, and same with y.to device. Beautiful. And then what do we do for an evaluation step or a test step? Well, of course, we do the forward pass, and we're going to, let's call these test pred logits and get the raw outputs of our model. And then we can calculate the loss on those raw outputs, calculate the loss. We'll get the loss is equal to loss function on test pred logits versus y. And then we're going to accumulate the loss. So test loss plus equals loss.item. Remember, item just gets a single integer from whatever term you call it on. And then we're going to calculate the accuracy. Now we can do this exactly how we've done for the training data set or the training step. So test pred labels, we're going to, I just want to highlight the fact that you actually don't need to take the softmax here. You could just take the argmax directly from this. The reason why we take the softmax, so you could do the same here. You could just directly take the argmax of the logits. The reason why we get the softmax is just for completeness. So if you wanted the prediction probabilities, you could use torch.softmax on the prediction logits, but it's not 100% necessary to get the same values. And you can test this out yourself. So try this with and without the softmax and see if you get the same results. So we're going to go test accuracy plus equals, now we'll just create our accuracy calculation on the fly. Test pred labels, we'll check for equality on the Y, and then we'll get the sum of that, we'll get the item of that, and then we'll divide that by the length of the test pred labels. Beautiful. So it's going to give us accuracy per batch. And so now we want to adjust the metrics to get average, loss, and accuracy per batch. So test loss equals test loss divided by length of the data loader, and then we're going to go test acc equals test acc divided by length of the data loader, and then finally we're going to return the test loss, not lost, and test accuracy. Woohoo! Look at us go. Now in previous videos that took us, or in previous sections, that took us a fairly long time, but now we've done it in about 10 minutes or so. So give yourself a pat on the back for all the progress you've been making. But now let's, in the next video, we did this in the computer vision section as well. Did we create a train function? Oh no, we didn't. But we could. So let's create a function to functionize this. We want to train our model. I think we did actually. Def train. We've done so much. I'm not sure what we've done. Oh, okay. So looks like we might not have. But in the next video, give yourself this challenge. Create a function called train that combines these two functions and loops through them both with an epoch range. So just like we've done here in the previous notebook, can you functionize this? So just this step here. So you'll need to take in a number of epochs, you'll need to take in a train data loader and a test data loader, a model, a loss function, an optimizer, and maybe a device. And I think you should be pretty on your way to all the steps we need for train. So give that a shot, but in the next video we're going to create a function that combines train step and test step to train a model. I'll see you there.